Hello friends, welcome to my channel. On our second video for the Let's MLOps series that I just started, we're going to look at how to train a machine learning model, which is packaged using Flask, and how to track experiments using MLflow. Now first, I will track experiments of my machine learning model using MLflow locally on my computer, and then I will do the same remotely using DagsHub. To do the remote experiment tracking, I'll automate it using Jenkins CI/CD pipeline. And then after we generate our model and the artifacts, we will version it and then add the model to a registry. So please stick around for the entire video and let me know if you have any questions in the comment section below. Like, comment, share, and subscribe to my channel for more videos like this. Okay, let's get started. Now in MLOps, experiment tracking is very important. Let's say you have a machine learning model and you have data coming in. So you're constantly training the model. And so you constantly have different experiments. So each training you do on your model is an experiment. And each training also results in a new artifact of the model. Now that makes model experiment tracking very important. The more data comes in, it makes the machine learning performs better whilst you are tweaking around the model in the best possible way. All right. So in the first part of our video, we will look at an overview of the codes that we are using for this project. Now I have the code in the GitHub repository MLOps 02. I've also cloned this code in my local machine, which is the same thing here. To clone it, just open a location, click on the code and copy this link. And on your local terminal, you just do git clone. If you have a terminal like this, all you need to do is git clone. And then the link that you copied here, you just paste it in that location and press enter. And that's gonna clone your code. Since I've already cloned it to my local host, I will not do that again. Now, let's see what the code actually does. So first, you have some templates. Now, this template is what's going to serve the web page. So you have an index.html file inside it, very simple one. And then have some test cases here. If you want to test your code, you can use this to test it. Now, this code is actually based on the first project that we did, MLOps 1. So it's pretty much the same thing. And then I have app.py because I'm using Python. So I'm using Flask as my Python application packaging, which is still the same as the app.py that we saw in the MLOps 1 project. The only difference is I changed the port number. Instead of 5000, I've made it 5001. But you can still use port 5000. Still doesn't change anything. I have some requirements.txt file here. Again, we used this in the first project. The only new one that I've added to this project is the MLflow for our experiment tracking. All right, so that was app and requirements. Now let's go to training.py, which is the file that actually trains our model when we run it. All right, so first we import some packages here. Pickle, this will help us to build our artifact. You have MLflow, and then you have some other packages inside sklearn library in Python. Now to set up MLflow, the first thing you need to do is set up some experiment that will pick up the job that you're trying to run. So if this experiment is not available on MLflow, this code will automatically create it and it will set that as our experiment. Now this will help us to work under the project name Iris Model Training. So that is the first time you see MLflow here. Next is MLflow.start_run. Now this command will help us to start an MLflow run so that we can track the training of our model. And then over here, you see MLflow.log_param. This will help us to use MLflow to track log parameters. And in our case, our 3 log parameters are n_estimators, max depth, and random state. And of course, that's our model. We are using a random forest classifier model. Then you see another MLflow here, where we are logging the metrics of our model to MLflow. Some well-known metrics in machine learning: accuracy, precision, and recall. So when we host our MLflow server, we should have these logs, we should have these parameters, we should have this project name as well. And of course, the last part is right here. So after we've saved the model as a pickle file, it is also logged into MLflow. And then from there, we can version it and register the model. So this is a brief overview of the code that we are going to use in this project. So in this section, we will see how to run our experimentation on MLflow locally on our machine. Now, as you can see, I have a MacBook here. This is a MacBook Pro. It's my local host. Now, from the code that you saw earlier, there are some functions in here for MLflow to ensure that experiment is logged properly on MLflow. You have a set experiment, MLflow.start_run. And then we have log of metrics. And then we have log of parameters, log of metrics, and then we have log of the artifact. All right, with that, let's go into our terminal. So I'm opening a new terminal. By the way, the code is in the GitHub link in the description below. And please don't forget to like, comment, and subscribe to my channel. So I have my terminal ready. So the first thing I would do, you should install Python in your local machine. Just go to Google and search for how to install Python. You can install it using Anaconda, which is the one that I'm using currently. And then for this project, if you go to the requirement.txt, these are the packages or libraries that we need for this project. And so for that, we need to have them installed. To install these packages, I'm going to use the command pip install. I don't want to cache any directories. So, of course, this is going to take a lot of space. That's why I don't want to do that. Other than that, you can just use pip install -r requirement.txt. Run this command, and this should install all the packages that are in the requirement.txt. With that, let me clear the screen. So all our packages are installed. Now we have to train the model. To train the model, we use the command python, and the file of the model is train.py. So python train.py, press enter. Now you can see some information here, and you can see some 2 new directories created in our home directory here that we are running the project in. Now the first ML run contains all the different runs that we are going to make, different experiments that we will run. Okay. And then the model is a directory where the artifact is saved, the artifact of the model. Remember, it's a pickle file. So this is the model package as a pickle file. And of course, ML run, you see run 0, run that, it gives you some number. And then over here, so what MLflow did is it checked the MLflow server and realized that an experiment with this name does not exist. If it does not exist, then it will create it as a new experiment. If it already exists, then it will log this experiment to it as a new experiment with the timestamp. And so you see a model is trained and logged to MLflow successfully with an accuracy of 1.0. The accuracy is just the accuracy score of our model. Now this is a very simple model, so it shows 100% accuracy, but that's not very realistic for normal machine learning projects, right? This is just for testing. So our model is trained, Next, I'm going to open a new terminal. I know this is our old terminal. Now on the new terminal, this is where I will run the MLflow server. Now I have prepared a command here. To run the MLflow server, you run the command MLflow server -- host. And since I'm running locally, I'm using localhost. Localhost is the same as 127.0.0.1, right? And then the port is 5001. Now remember in the Flask application, I'm using the port 5001. So this has to be the same, okay, so that you can listen. All right. Now you can press enter to run this command. Okay, so you can see that it's running. Now it didn't exit the terminal, which is why I opened a new terminal to run this. That's because if you exit out of this, MLflow will also not work on your web browser. So you can use this, open this link on your browser, or just go to your browser and type localhost port number 5001. Press enter. And that should open MLflow dashboard. Now you can see the iris model training, which is exactly the name of the experiment that we have right here. Created that successfully. So if you click on it, you see 3 minutes ago. And the run name is called Capricious Rat 460. Now this is the training that we did earlier, right here. This is the first training we did. Look at the timestamp, it's 1:16:06. If you click on this, you will see the time 1:16:06 or 08 in this case, but it's pretty much the same thing. You see some logs here. Remember, we logged the parameters. These are the 3 parameters. We logged the metrics, accuracy, precision, and recall. This is all the logs for that. And then we log the artifact. The artifact is a pickle file, iris_model.pickle, which is right here. This file. All right. Now at this point, I'm going to train the model multiple times and see if you will find it on our MLflow dashboard. So I'll run one more, the same train command. Okay, so it's trained it again. Now remember, now the experiment here exists, so there's no need to check or to create a new experiment. It will just do the training. So that's the second one. I'll do another one. Whilst I'm doing all this, the MLflow server is still active. So it's listening still. So I've done 2 trainings here. Let's go to MLflow dashboard, refresh this. And you see these are the 2 trainings that we just did. And if you click on each one of them, you should see the logs, the parameters and metrics, and the artifacts. So if you make any changes in the model, just retrain it, and that will log it on your MLflow dashboard. And if you click on the latest one, you should see the new model that you can use for your own stuff. Now, in the next session, we will look at how to track a machine learning model whilst you're training it remotely. Now you can see that I'm running all this locally. If I go to my Visual Studio Code and I do Control-C on my terminal to abort this MLflow master, if I refresh this right here, it's off. Now, a lot of times you'll be working on a team, so you'll be collaborating with other colleagues, right, on a project. So how do you make sure that you have the model, the artifact, the parameters, and all the logs in one place such that it's accessible and that if you exit out of your terminal, it doesn't shut it down for every single person? Okay, so in this part of the video, I'm gonna go to DagsHub.com. You can go to dashboard. You can sign in with your Gmail account, or you can create an account for that. Now, this will help you to track your model experiment with MLflow remotely. It also has an inbuilt version control, kind of like GitHub, which also makes it very easy to version your code or even models. So first, I'll go here and create a new repository. So click plus new repository, and I'll create a blank repo. Now for the repository name, I'll call it MLOps 02 MLflow remote. I'll keep this as public. Create repository. So you can see 0 experiments, 0 data sets, and our repository is empty. Right. Now, similar to GitHub, this gives you a link or a command to clone it and add some files and stuff like that. Right. So I'll copy this first link. And on my terminal here, it has the git clone already, so I don't have to add anything. I'll just paste it here. And this has cloned, but it's currently empty. MLOps 2_ MLflow. So this is the directory. ls, and there's nothing in there. So this was what I just ran. Now I can create a README file using this command. And then to commit all the changes or any files that I add here back to this repository on DagsHub, I run all these commands. Now, I'm not going to add the README file because I'm going to take the previous files that I used in the previous part and I'll modify that to use it here. So I'll get all the commands in here at this location and then I'll push the changes to our repository. Okay. So as you can see in our repository, I've added the commands that we had or the codes that we had from the previous section. You have the templates, the test files. If you want to do some tests, I have a Jenkins file here, an app.py, requirement.txt, and have train.py. I have the same info on this side on my local host. This is the train.py. This is the Jenkins file. It's pretty much a skeleton. I'll fill in the commands later. And then you have the Flask application here. And of course, you have the requirement file right here. Now you see that there are only a few changes that I've made comparing this file to the one that we used in the previous part of this project. The only new thing here in the train.py is right here. Everything else is the same thing. We are still logging with MLflow everywhere. Login metrics and the artifact. Now, here we are going to put the URI because we want to log it remotely. You use the URI for DagsHub for this first variable. And then the username. Find the username right here for this. And then we will create a password for this. Now, the password is going to be a token. Similar to creating tokens for GitHub accounts to sign in or to use that as a password, similar thing for DagsHub. And then to automate the whole process, that's why I have this Jenkins file here. So I'll create a Jenkins server that would automate the whole training and everything. And then we will check the results on the DagsHub repository to track our experiments. Now in your DagsHub repository, you see files, data sets, experiments. So this is where all the experiments that we run will be at. They'll all be lined up here. If you have any models, they will be in this section. All models will be here and so forth. So currently we are in files and these are our files. So before we even start training the model, I'm gonna open a new terminal, and I'll use this terminal to create my Jenkins server. I'm using Jenkins to automate the whole process of first loading the repository to DagsHub, installing packages, training the model, and you can add more steps, but I decided to keep only these 3 steps. I don't want to do it manually, and so that's why I created this Jenkins file for that. So I need to have a Jenkins server, and for that I'm going to use a Jenkins container to set it up. Now if you go to my Docker Hub repository, by the way, my username on Docker Hub is iquantc. I have several Docker images here. Now I have built a Docker image that is ready to use on Mac OS, and the name is iquantc Mac OS Jenkins Docker. Now you can use this Docker image to run Docker in Docker commands on your MacBook. Again, if you want to know how I created this, if you go to my YouTube channel, the process of creating that Docker image is based on this video. It was out of this video that I created that Docker image. Now, if you are working on a Linux machine, you can use this command to do the same thing. So to first do this on my Docker Hub account, since this is the image I'm using, I'll click on it. And if I go to tags, by the way, you can see the description here. This is a Jenkins Docker image for running Docker jobs on a Mac OS computer that's running Docker Desktop. So you should have Docker Desktop installed on your Mac OS. All right, let's go to tags. And this is my image. So first I will copy this and use that to pull the Docker image to my local machine. So this will pull it. Press enter. Okay, pulling is done. So if I do Docker images, this is my Docker image right there that I'm going to use. So clear the screen. And then to run it, I'll use this command. So Docker run in detached mode. And I'm calling my server Jenkins master. Of course, it's in privilege mode. Port 8080 for Jenkins UI, port 50,000 for Jenkins agents. And I'm mounting the Docker socket of my local host, which is my MacBook, to that of the container. And I'm mounting the working directory for my Jenkins container. I'm using user root, and this is the name of the Docker image that I just pulled. So press enter. And that should start your Jenkins container. So if I do Docker PS, that's my Jenkins container right there. Now it takes a while for the Jenkins UI or UI server to come up. So after a few seconds or a few minutes, go to your local machine on a browser, go to localhost 8080. Now the 8080 is from right here. The Jenkins is exposed on port 8080. That's the Jenkins UI. This one is for any Jenkins agents that you may have. Currently, we are not using any agents, so you see that I will not use this. By the way, if you want to know how to set up Jenkins agents, I have some videos on my channel right here. You can set up Jenkins agents using a container, another Docker container. You can use Kubernetes pods, and I have another video on how to use a virtual machine or a cloud EC2 instance or virtual machine to create a Jenkins agent as well. So these are the reasons why we need this 50,000 port. But currently we don't need this in this project, so I'll just skip it. Let's do setup. All right, we need administrator password. And for that, we have to do Docker logs in the name of our container, Jenkins master. Now this right here is the administrator password. Copy it and paste it in here. Continue. and then I'm going to install suggested plugins. Now this may take some time, so I'll pause the video and come back once it's ready. Okay, now for the username, I'll just give it admin, password, admin, confirm password, admin, full name, admin. This has to look like an email address, so admin@admin.com. Continue. Save and finish. Start using Jenkins. All right, so our Jenkins server is done. Now you can see we have some error or something here. In a production environment, it's best to add a built-in node, okay, which was what I was showing earlier about using Docker container or Kubernetes or a virtual machine as a build agent. Currently, I'm not using it, so we can dismiss it. But it's best practice to create a node, attach it to this Jenkins server, and use that as your build node in production environments. So I'll just dismiss this one. Now let's go further to do some installations. On my terminal, I'll clear the screen here. I have Docker PS. It's my container. First, I'll try to log in into my Jenkins container. I'll use docker exec-it. In the container name, just copy this. I'm using bash to connect to it. So I'm currently inside the Jenkins container as root. So first, I'll just update and I'll upgrade. So I've done my update and upgrade. Still within the container. Now, my code, everything is in Python. So I need to ensure that Python is installed. If I do Python version on my container, it's not found. So this shows Python is not installed. So I'll do apt install. And I'm installing Python 3 -y. All right. So if I do Python 3 -- version, this is done. But if I do Python -- version, it's not found. That's because you need to add a 3 to see the version. But I want to be able to run Python with the command Python. Take, for instance, if I want to train it, I want to run the command Python train.py, not Python 3 train.py. Okay. I don't want to keep adding the number 3. And so what I would do is to create a symbolic link that will link Python 3 to Python. And I'll use the location of the user binaries for Python 3. Now link this to Python. Press enter. And now if I do Python version, I have the same version as the Python 3 version. So that if I run Python train.py, that should still give me the same results. Next. Now, when you look at the second stage, the first stage, we will just clone the repository. The second stage here, we're using pip to install some requirements. Now, by the way, the requirements has these packages that we need to install. So this pip also has to be installed. Before I do that, I'm gonna check Python -m pip -- version. Now you see that pip is not found. This module is not found. So I need to install pip. And I can install it using apt install. By the way, I will use Python 3 or Python, either way is still fine. Python 3 pip -y. And this should easily install pip. Okay, so pip is installed. If I run the version here, you can see the pip version is also found right there. I've installed everything I need to install so far. So I will exit out of the container. So I'm currently outside the container. Clear the screen. And then I will restart my container after all these installations. So Docker restart. Container name. Press enter. And it's restarting. When I go here and let's say I go to dashboard, you see that it will be loading. All right, sign in with the username admin, password admin. Let's enter. Okay, so there we have it. We have our Jenkins ready. Let's go back to our DagsHub. This is our DagsHub repository. Okay, so I'm gonna be making changes to our Jenkins file. First, I will need DagsHub MLflow URL. I'll need a tracking username for MLflow, and I will need a password for MLflow. And then I will need to clone the DagsHub repository. So I'm going to do all this one by one. All right. So first, let's go to DagsHub here. Then on DagsHub, go to your account, go to settings. And then on the left side, go to tokens. By the way, you see default access tokens and you have managed personal access tokens. I'm going to use this to create a password. Now that password is what I'm going to use for the MLflow tracking password. It's the same thing I'm going to use as a credential inside my Jenkins. This is an old token, so you can ignore that. I'll generate a new one. So generate new token. For the name, let's call it, our project is MLflow. Let's call it MLflow Remote. MLflow Remote DagsHub. That's the name that I'm giving it. Generate token. So this is the token. So copy this. Save it somewhere safe. Now if I go back to tokens, this is the token I just created. That was the name I gave it. I will copy that and save it as well. And then I will go to my Jenkins, go to manage Jenkins, credentials, here it is, global, add credentials, and it's going to be username with password. Next, of course, our password is exactly what we just created, the token. Wherever you pasted it, copy and paste it in here. For the username, on our DagsHub account, if you click on this, this is the username. The username is iQuant Consult. Or if you're not too sure, go to profile, and this is the username. You can change it, of course. So I will just copy this and paste it here for my username. And for the name, I'll use the same name I used in DagsHub for the token. Just use the same name. I'll copy that, paste it here and there. Create. And that should create the token. Now let's go back to the dashboard. I'm going to create a pipeline job that will run this project. Now, before I do that, let's do the changes in our Jenkins file. Okay. First off, in our train.py, I have these values. I have the tracking URL, and I have the username and password. The tracking URL, since it's DagsHub, this is https dagshub.com/account consult/ by the way, you can get the link from up here if you go to the repository. Let's go back. This is our repo. This is pretty much the URL that we need. Right. So I can just copy this. And in my train.py, I'll replace this whole thing with it and then add .mlflow. So that is our URL for tracking. Username. Our username, we just found that is icon consult. We just use that for the credentials. For the tracking password, by the way, the train.py file is currently not on the Jenkins container. So I can just copy and paste the token that I created here, like this. By the way, this is just a practice, or in a dev environment, so I can paste it in here like that for the tracking password. But in a production environment, the best thing or your best bet is to create a .getignore file and then add this content to that file, put it in there so that when you push it, it doesn't expose this token, so that you can reference the file in here. But since it's dev environment, I will just keep it as it is, like this, as our password. Now with that, I'll save it. Everything else remain the same. So train.py is pretty much fine. Now let's modify our Jenkins file. First, it's the tracking URL. So this is it. I will copy this. This is the first one. That's the DagsHub MLflow URL. Paste it here. Username. Icon consult. Paste it there. Then the password. Because we are currently, this Jenkins file is actually from the Jenkins server, we can reference this password instead of the plain text or referencing it from a file. You can reference it as credentials and then the name that we gave it in the credentials. Okay. So when you went to the manage Jenkins credentials, this is the name that we gave it. This is it. So I'll copy this and reference this inside credentials. Paste it here. Next, let's fill in. I'm going to close this terminal for the meantime. I need more space. Let's fill in the commands here. First is the command to clone the DagsHub repository. This is the DagsHub repo. If you want to clone it, click the remote. This is the clone link. This is the HTTPS link. So I'll copy this. And then in my Jenkins, I'll go to dashboard. So I will create a new job or new item. This will be MLflow, remote DagsHub. Let's use that name. Pipeline. Okay. You can add some stuff here, but I will leave it as it is. And then for the pipeline script, I'll use script from SCM. And the SCM is Git based. Now for the repository URL, that's exactly what we just copied from here. Okay. Paste that. Select the credentials for it. The branch here is main. So this has to be main. Everything else can remain as it is. By the way, we are looking for a Jenkins file. So let's go to pipeline syntax. And this will help us to generate the script. So go to Git. Paste the repo URL again, and copy it one more time. Branch is main. Credential is right here. Generate pipeline script. This is it. I will copy this command. And then inside my Jenkins file, I'll paste it in here. It's quite long, but I just pasted it in here. Now save this. Now apart from this, there's nothing more I have to do in here. This second stage is just using pip to install requirements.txt. And this is doing Python train.py, which will train the model. Everything looks good so far. Let's go ahead and use our terminal. I'm gonna open a new terminal. By the way, this is the old one stored here by the screen here. And then I will do git add dot git commit. This is, let's say, added git clone command, git push. That should be pushed. Let's go to our DagsHub. Refresh this. Now you can see this is the Jenkins file here. And this is exactly what we just did. We added a git branch command. And then this information that we added. We check the train.py file. That should also show you something like this environment variables, and then the model itself. By the way, if you have any questions, keep it in the comment section below and I'll be checking them. And also don't forget to like, comment and subscribe to my channel for more videos, as I'm a small and new YouTube channel and I'm trying to grow. So please subscribe and like my videos for more videos like this. All right, with that updated, I'm done with the pipeline script, so I can close this. By the way, in our DagsHub, the file I'm gonna use to run my job is Jenkins file. So this has to be Jenkins file. Apply and save. Go to build now. Then we check the console output by clicking these 3 dots. You can see the first step, it's obtained the Jenkins file from DagsHub. So it's recognized it. So you can see that the git checkout part is done. And now it's installing the packages inside requirements.txt. By the way, you see that pip is installing, but you can't see any commands showing on this console. And that's because if you look at the requirement.txt, the way I reference it inside the Jenkins file is that whatever output that is generated from the installation should be sent to a file req output.txt. So that's why you are not seeing the console output of the installation. Okay. Sometimes it's a little too much. You have to scroll so much. That's why I'm redirecting it to another file. Okay. So you can see that the installation is also done. Now I started training the model, and you can see that the model trained successfully with an accuracy of 1.0, which is exactly what we got when we ran the training of the model on our local machine. And you can view this training. By the way, whenever it trains it, it assigns some name, some random name to that particular training. If you click this, this should take you to DagsHub directly. You can also view it right here, right? You see that everything is a success. You can click on the links, or you can go to your DagsHub account here, refresh it, With experiment, you see this 0 will change to 1. Exactly. Because we just run it once. There's one experiment. All right, here it is. And you see the name is Traveling Chimp 208, which is exactly the name that is given right here. Traveling Chimp 208. Accuracy is 1.0. Same here, accuracy is 1. Right? Now, these are the stuff that we logged. You have the random state. Let's go to the training.py file here. So in our model, we logged these 3 parameters. Okay, those are these 3. And then we went out to log these other 3 metrics, which is also in the same train.py right here. And that's exactly what you see here. Now you can run it multiple times and it will start appearing. All of them will appear on the side. So just gonna go back and build one more time. Maybe multiple times like that. Just to see how the experimentation looks like. So you can see all of them are successful. Go to DagsHub. Let's refresh this. You see 4 experiments, right? Exactly the number of runs here. There are 4 of them. And all of them will appear here with the random names assigned to them. This was the first one, second, third, and fourth. And for all of them, the accuracy is still 1 everywhere. This is a simple machine learning model, so it's fine. By the way, this is the experimentation on DagsHub. If you want to see it on MLflow, you can go to MLflow UI right here using this button. By the way, remember the name of our experiment is Iris Model Training. And these are the 4 trainings we just did. And if you go inside each one of them, you see more information about it. Recall, accuracy, and precision. These are the parameters. If you go to artifacts, this is the model. The model is called iris_model.pickle. Right, that's the model file. Or in the DagsHub repo, just click any one of them. Let's say this one. See similar dashboard. These are the parameters. These are the metrics. If you go down, you see artifact. This is the model. iris_model.pickle. Okay, so that's pretty much how you would use DagsHub to train your machine learning model and to track your experimentation with that particular machine learning model, especially if you want to do it remotely. Let's go back to experiments. Now, if you want to share from MLflow, you can click here to share the model. On DagsHub, let's also look at how to version the model and to register the model as well. Now, for that, click the particular experimentation. Maybe this one gave you good results. Click on it. And you see register model on this side. You can click this. And you can give the model some name. Let's say add new model. And the model name, I'll call it, this is resilient zebra. Save it. And this shows that model is registered. If I go here, you should see that this is a model tab. If you click right here, you see all models that are registered. This is the model you just registered. Now, this is the first version, right? So by registering, you are versioning it at the same time. Go in here and you see the version 1. So if you rerun this and you want to version the same model, the next one will be version 2 and so forth. Click on this and you should see more information about that particular model. This is the artifact. These are some metrics. And you can delete it. You can also promote it. So as you know, in an experiment, it's not always you get a good model, especially with the data that you're working with. If you make some tweaks in the model, sometimes the performance is not that great or it gets better. So you can have multiple versions. And so if you have a particular version that gives you a very good accuracy or a very good metric, you can promote that model as being the best one for you compared to all the other ones or all the other versions of that same model. So on this tab here, you have your experiment, you have your models, you can collaborate, you can annotate, and if you go to files, you have your contents of your repository right here. And everything is automated in one place on DagsHub. Before I end this video, one more thing, that you can go to settings here and you see that DagsHub can integrate with some other tools as well. Go to integrations, see that you can integrate it with MLflow like we just did, DVC, New Relic, S3, Google Cloud, Azure Blob, Jenkins Label Studio. So in this model or in this experiment, we use Jenkins and MLflow. You can use it to integrate with these other tools as well. Thanks for joining me on this video. Please like, comment, and subscribe to my channel for more videos like this. And I'll see you on the next one. By the way, before we go, don't forget to stop the Docker container. So Docker PS. You can close all of these, or you can log out. Either way, it's still fine. Or if you do Docker stop this container, the container name is Jenkins master. This will stop the container. And so you see that Jenkins will not work anymore. Just close it. And DagsHub, this is an account I can sign out and close it. So that's it. If I do Docker PS, so all my containers have exited or I've closed all of them. So thanks for joining me on this video. Please like, comment, and subscribe to my channel for more videos like this. And I'll see you on the next one.